Today I'll talk about Rayleigh's method. So first, what is Rayleigh's method? A technique in dimensional analysis used to establish the relationship between physical variable through a power law. Rayleigh's method simplifies complex problems and provides insight into how different variables influence physical phenomena. Now, what are the applications of Rayleigh's method? So Rayleigh's method commonly used in fluid dynamics, heat transfer and material science. It helps derive empirical equation from experimental data, and it is also useful for scaling laws, modeling and predicting system behavior. Now I'll show you what are the steps to establish dimensionless equation by using Rayleigh's method. So Rayleigh's method for dimensional analysis. So step number 1, identify dependent and independent variables. Suppose in given system, if we want to find out the dimensionless equation, so first in the system we must identify dependent and independent variable. So what does it mean? So identify the dependent variable, the one you want to understand or predict, and that independent variables, those that influence the dependent variable. So that is the step number 1, identify dependent and independent variable. Now step number 2, express dependent variable as a product. Now we know what is dependent variable and independent variable. Now express dependent variable, suppose y, as a product of all the independent variable. Suppose independent variable is like x1, x2, x3, so that y will be the product of all independent variable. So that raised to unknown integer exponent, use a constant a to represent the proportionality. Now here, so y is equal to a into x1 to the power a. So x1, x2 and x3 are the independent variable, x to the power b into x3 to the power c. So here a, b, c are unknown exponent. Now step number 3, equate indices of fundamental dimension. Now after equate the indices of the fundamental dimensions like length, mass, time for each variable in the equation. The result in k independent equation where k is the number of fundamental dimension. So for example, if there are 3 fundamental dimension, so like L, M, T, you will get 3 equation by equating the power of L, M and T separately. So when I will solve one example, you will more understand the steps of Rayleigh's method. Now step number 4, solve for dimensionless group. Solve the system of k equation to obtain the values of the unknown exponent b, c and the constants a in the equation. These values give you dimensionless group. Now step number 5, express dependent variable in terms of dimensionless group. So use the dimensionless group to express the independent variable y in terms of this dimensionless group and constants. The final equation will be dimensionally constant. So these are the 5 steps of Rayleigh's method. Now I am taking one example. So here in that example, the resistance force R of a supersonic plane during flight can be considered as a dependent upon the length of aircraft L, then velocity v, air viscosity mu, air density rho and bulk modulus of air k. Now the functional relationship between resisting force and variable is obtained using Rayleigh's method. Now we have to find out a dimensionless equation to get resisting force. Now what is bulk modulus? Bulk modulus is nothing but that change of pressure by change of volumetric strain. So that is bulk del P by del V by V. P is pressure and V is a volume. Now step number 1. So first I already talked about that. step number 1. So identify dependent and independent variable. Now in that problem, so here that R is a, in this problem R is a dependent variable. So that is resisting force is a dependent variable. This is the force acting on the plane due to the air resistance during flight. It is a variable we want to understand or predict. Now independent variable, so that is length of aircraft, velocity v, air viscosity, air density and bulk modulus of air, that is K. Now step 2. So step 2 is express dependent variable as a product. Now here, so dependent variable are as a product of all independent variable, length of aircraft, velocity, air viscosity, air density, bulk modulus of air. So raised to unknown x component along with a constant of the proportionality A. Now we can write R is nothing but A into L to the power A, V to the power B, mu to the power C, rho to the power D and K to the power E. So now express dependent variable as a product. So A is here proportionality constant. Now here R is the resisting force dependent variable and A is constant proportionality, and A, B, C, D and E are unknown exponent that we will determine using Rayleigh's method. Now we got that expression of dependent variable is equal to the product of independent variable. Now here step number 3. So it equate indices of fundamental dimension. So first we have to get the dimension of all these variables. So now resisting force unit is Newton. Newton is nothing but kg meter per second square. Now if I write the dimension will be ml to the power minus 2. Now next is length of aircraft. So length unit is meter, dimension L. Velocity unit is meter per second. Okay, so dimension is L to the power minus 1. Then air viscosity mu unit is kg meter second, dimension is m L to the power minus 1 to the power minus 1. And then air density kg per meter cube, that is unit, so dimension is m L to the power minus 3. And then bulk modulus. What is bulk modulus of the air? That is bulk modulus is a measure of how resistant a material is its compression. It is defined as the ratio of pressure increase to the relative decrease of material derivative. So K is nothing but minus V by dP by dV, and that units is unit of bulk modulus Pascal of Newton per square meter, Newton per meter square. So dimension will be meter L to the power minus 1 and T to the power minus 2. Now we have all this dimension. Now we know the equation we got from earlier slide. So R is equal to A to the A, L to the power A, V to the power B, mu to the power C, rho to the power D and K to the power E. Now we have to put all the dimension in that equation. Now if I put all this dimension, so we'll get this equation AML. So here AML to the power minus 2. So this is here A L to the power A. So L to the power A. So ML LT to minus 1. So whatever dimension we have here, so using that dimension we got one equation. Now step number, so this is the equation we got, means after getting that equation if we put all these dimension, so we'll get this big equation. Next step number 4. Coming to the step number 4, so solve for dimensionless group. Now here that is ml to the power minus 2, and we put all these dimension for all these variable. So now if we rearrange, that will be ml to the power minus 2, a to the power mc plus d plus e, l to the power a plus b minus 3d minus e, t to the power minus b minus c minus 2e. Now again if we do that, so that will be, so here m to the power 1, l to the power 1, t to the power minus 2 is equal to whole equation. Now here let's match the dimension. So for mass, so left hand side the power of m is 1, so 1, and right hand side c plus d plus e, so one equation. And okay, length, for length, one on the left side is 1 and right hand side is a plus b minus 3d minus c. For t, one side of the on the left side minus 2, right hand side minus b minus c minus 2e. Now we can write the equation for each dimension. So for a mass, left hand side 1 is equal to c plus d plus e. For length, we'll get left hand side is 1 is equal to a plus b plus minus 3d minus 2, and for time left hand side that is minus 2 and right hand side minus 2 is equal to minus b minus c and 2e. So we got 3 equation, and here variable is actually 5. So now we have to express any 2 variable with 3 variables. Okay, so now here step number 4. So now you can write the equation. So that is all this equation. So for mass 1 is equal to c plus d plus e. Now here we are calculating what is d. D is equal to 1 minus c minus e, and for length we got 1 is equal to a plus b minus 3d minus c. So now here, so we get, if we put d values, we will get b is equal to nothing but 2 minus c minus 2e. We can solve this problem. So we plug d value in that length and we will get what will be the b. So plug this value of d and we will get the b. Similarly for time we know that minus 2 is equal to minus b minus c minus 2e. So now we have to plug b here in that equation 3. Now we will get, if we plug all this value, so we will get a is nothing but 2 minus c. So d we will get 1 minus c minus c. So b we can express 2 minus c minus 2e, and a can express 2 minus c. Now and so a is equal to 2 minus c. Now step number 5, express dependent variable in terms of dimensionless group. Now we substituting the values in the equation and we get, so we are substituting all this value here. So whatever we get a d b a, so we are substituting here. So that will give r is equal to, so we got that exponent and we have put that exponent in that equation. So it will be a l to the power minus c b to the power minus c minus 2e mu to the power c rho to the power 1 minus c minus e a to the power e. Now we have to reorganize and we will get that this equation. So r is equal to a rho l square v square by mu into rho v l to the power c k by rho v square by e. So here that mu by rho v l is a dimensionless number, and k by rho v square, so that is also dimensionless number, and r by rho l square v square will also be dimensionless number. So ultimately we will get r is equal to a rho l square v square phi mu by rho v l into k by rho v square. So this is a whole equation. So here r is a resistance port is equal to nothing by rho l square v square by this, or we can, if we reorganize r by rho l square v, so that will be function of the dimensionless group. Okay, so this is the problem, that using the Rayleigh method, so we can get that dimensionless equation. So that's it. Thank you.